Oh, hey, Evan, what are you doing there?
Just drilling some holes in the wood. You know how it is.
Yes, I do. Hey, did you know that drill bit you have that you're using has tungsten in it?
I did not.
No. A mix between tungsten and carbon, actually.
Really?
See, tungsten and carbon have the two highest melting points, meaning that they can withstand the high temperatures that come with the spinning of the drill without melting. In fact, tungsten carbide is used in many other high-power cutting tools, such as chainsaws and the tips of diamond drills.
Wow, that's pretty neat. But which one has the highest melting point?
Well, carbon does, but tungsten has the highest melting point of all the metals. Like, by the time that tungsten is melting, all other metals, such as iron, have already reached their boiling point.
That sounds pretty metal. That's pretty interesting. Tell me more about tungsten.
Well, let's start with tungsten on the periodic table. That number at the top is its atomic number. This tells you how many protons, positively charged particles, and electrons, negatively charged particles, are in the atom. Tungsten has an atomic number of 74.
Oh, that means it has 74 protons and 74 electrons.
Exactly.
What's that number on the bottom?
Oh, that's the atomic mass. It's an average mass of all the different types of isotopes for that element. This is determined by the number of protons and neutrons in the nucleus of the atom. This is tungsten 180, meaning it has 74 protons and 106 neutrons. Tungsten's average atomic mass is 183.84.
Okay, moving on. What does the W mean?
Oh, that's the chemical symbol of the element. All elements have them. They're a shortened version of the element's name, which is useful when writing out chemical formulas.
Why is it W? Tungsten doesn't have a W in it.
Well, sometimes it's not always a shortened version of the element's English name. Let's take iron, for example. Iron's chemical symbol, Fe, is a shortened version of iron's Latin name, ferrum. Tungsten is a bit different, however. You see, tungsten's chemical symbol comes from its original name, wolfram.
Wolfram?
Yeah, it comes from the mineral that tungsten was first found in, wolframite. You see, tungsten is never found alone in nature. It's always found in compounds with other metals.
Wow, that's interesting. And of course, there's the name of the element tungsten. Not much there, really.
Well, a little fun fact. Tungsten is Swedish for heavy stone, which is pretty self-explanatory.
So that's tungsten on the periodic table. What's next?
Actually, there's more. Look at the group tungsten's in. The periodic table is organized by groups, among other things. The large chunk in the middle of the table where it dips down is the transition metals. This means that all elements in this group contain somewhat of the same properties. The transition metals are all good conductors of heat and electricity. They can be hammered and bent easily. They have high melting points, with the exception of mercury. They all form colored compounds, and much more. Transition metals also have 0, 1, or 2 valence electrons.
What are those?
Well, I'll explain that later. Take a look at the row tungsten's in.
Yeah, it's the sixth one down. What does that mean exactly?
The row that the element is in tells us what period it's in. Periods tell us how many energy shells are around the nucleus. Energy shells are those rings that hold electrons. See, tungsten has 74 electrons, which we know from its atomic number. Now, 74 electrons is too many to hold on just one energy shell, so the electrons are spread out through different energy shells. The period lets us know how many energy shells the electrons are spread out. As you can see, there are 2 electrons in the first shell, the shell closest to the nucleus. There are 8 in the second shell, 18 in the third shell, 32 in the fourth shell, 12 in the fifth shell, and 2 in the outer shell. These 2 in the outer shell are called valence electrons, which are critical to the bonding process.
Oh, so that's what those are. Alright. Well, how does tungsten bond?
Well, tungsten can bond in 2 ways. Ionically, a bond between a metal and a non-metal, and metallically, a bond between 2 metals.
Let's start with ionic.
Alright, let's take tungsten carbide, the compound that made up your drill bit. Now, remember how tungsten has 2 valence electrons? Well, we can tell from carbon's place on the periodic table that it has 4 valence electrons out of 8. In the ionic bonding process, atoms want either 0 or 8 valence electrons, and it's easier for tungsten to lose 2 and drop to 0 than for it to gain 6 and go to 8. Likewise, carbon is an equal distance from 0 and 8, so it doesn't bond often, but usually the metal gives its electrons to the non-metal.
Oh, I think I got it. So tungsten loses its 2 valence electrons and gives it to carbon, like so. Now carbon has 6 valence electrons. Jinkies, I almost had it.
Fret not, friendo. All you need to do is add another tungsten atom into the mix.
Oh, okay then. Alright, so this new atom loses its valence electrons and gives it to carbon. Now the carbon atom has 8 valence electrons, and it now forms tungsten carbide.
Not quite. There's still one more step. You see, the atoms haven't quite actually bonded yet. You know how tungsten's atomic number is equal to the number of protons and electrons in an atom?
Yeah, what about it?
Since the protons weren't affected by the bonding, tungsten now has more protons than electrons. The balance of the protons and electrons normally cancel out and made the atom neutrally charged. But now...
There's more protons than electrons, and the atoms are now positively charged.
Exactly. These charged atoms are called ions.
Then that means that carbon has more electrons than protons, and is now negatively charged ion. And since opposites attract, they bond together. And now you have tungsten carbide.
There you go.
Well, what's metallic bonding?
Well, metallic bonding is when two metal atoms bond together to make alloys. When tungsten bonds with steel, it makes alloyed steel. Alloyed steel can be made with other elements such as chromium and nickel. When tungsten is made into alloyed steel, it makes the steel resist extreme temperatures.
How does that work?
When metal elements want to bond, they drop all of their valence electrons to form a sea of electrons that are in a rigid pattern. This makes it easier to manipulate the metal.
Wouldn't that make it hard to move the metal and make swords and things?
I was getting to that. When the atoms lose their valence electrons, the atoms become positive and get attracted to the sea of electrons, forming the bond. Since positive ions aren't attracted to each other, they don't go next to each other when bonded. This forms a rigid pattern between the electrons and the ions, which can be easily pounded or drawn out into thin sheets. The compound would be considered malleable.
But
the electrons and positive ions still form a very strong bond, which stays when solid. The reason that swords are heated before being pounded into shape is to get the particles moving, which makes it easier to push the compound.
Oh, that actually makes a lot of sense. So that's bonding for tungsten, right?
Pretty much.
What's next?
How about we talk about tungsten physically instead of chemically?
Swagalicious.
Let's start with what we were talking about to get us into this conversation, tungsten carbide. And as I said, tungsten and carbon have the highest melting points of all elements, making them ideal for high-power cutting tools such as chainsaws and drills. And as I said during the metallic bonding lesson, tungsten bonds with other metals and steel to create super alloys used in space and aircrafts, because the metals make it hard and strong and keep its shape, while the tungsten gives it the heat resistance it needs so that the metal doesn't just melt right off the spacecraft when it's launching off.
That's pretty metal.
You already said that, fun.
Oh, okay. Rats. What else?
Well, tungsten itself is pretty malleable. It can be pounded into shape and keep its strength, and this makes tungsten ideal for light bulb filaments.
That is tungsten?
See, that's exactly why tungsten is a good choice for light bulbs, because of the electricity that makes the light bulbs lead up after a long time of being lit on, and the electricity itself makes the light, which is the basic principle of light bulbs.
What else?
Tungsten doesn't really have many other uses, but the ones that it does have are integral to the technology we use every day.
That's pretty cool. That's pretty cool, bro. I've learned a lot about tungsten. Thanks.
You're welcome.
Now I can drill with a purpose.